We're now going to look at uniform motion problems. And the idea behind a uniform motion problem is that we're going to make an assumption that we have some object or person traveling at a constant speed. So we're going to assume that the speed is the same from the beginning of the trip to the end of the trip. We know this isn't really likely to be the case, but most of the time most of us like to travel that way anyway. We like to get up to a certain speed and then stay that speed, especially if we're going for long trips. So we're going to make the assumption that that's just the way it's working. And when we do this, if an object is moving at an average speed r, the distance covered in time t is given by d equals r times t. And so here's our uniform motion formula. We're going to use this formula in every problem, but not every problem is going to be set up exactly the same. They're all going to use it, but they're all going to use it in a different way. So let's show an example. Here's a problem, and we're going to use the uniform motion to solve this. And what we're looking at is a biathlon. Suppose that you have entered a 62-mile biathlon that consists of a run and a bicycle race. During your run, your average velocity is 8 miles per hour, and during your bicycle race, your average velocity is 20 miles per hour. You finish the race in 4 hours. What is the distance of the run, and what is the distance of the bicycle race? So again, step 1. Let's read it and find the question. The question is, what is the distance of the run, and what is the distance of the bicycle race? So we're going to have to find two distances. So let's also identify what we know and what we don't know. We have an average velocity of 8 for the run and an average velocity of 20 miles per hour for the bicycle race. We also know our total distance is 62 miles, and this is key, our total time is 4 hours. So here's what we know. We know that there's two distances being covered. One is the bike distance, and one is the run distance. We know that for each of those they're going to have a rate, a time, and a distance that they cover. So we're going to make this nice little table, and we're going to draw a picture. So we've got our run, and we've got us running as quickly as we can, and then we've got somebody us on a bike trying to cover this distance. And so we know we've got a speed of 8 miles per hour here and 20 miles per hour here. This is our rate. We don't know what our time is, and we don't know what our distance is. But we do know the totals. We know that, so we can put our 8 in for our rate, and we can put 20, whoops, I've got those backwards. Make sure you line them up right. 20 for the bike, 8 for the run. We do know that we have 4 hours total time, and we do know we have 62 miles total time. So we're going to pick one of these, and I'm going to let this one be my t. And so if we ride our bike for t of the 4 hours, then everything else goes here, so it's 4 minus t for the run. And then remember that our distance is always, by the way, we're doing step 2 and step 3 kind of together. But our distance is rate times time. So we can always take these, multiply them together and set them equal. to get 20t, and 8 times 4 minus t. Now, adding time together is not going to help us. We use that to separate already. So our equation is going to come from the distances. The distance spent on our bike plus the distance spent running has to equal 62. And now we get to start step 4. Again, every time we've got a linear equation, we're just going to go ahead and distribute to get 20t plus 32 minus 8t equals 62. Combine like terms. 12t equals, 12t plus 32 equals 62. We'll then subtract 32 from both sides. 12t equals 30. Then we divide both sides by 12, or multiply by 1/12. We reduce our fraction. Notice that 6 goes into both of these. So it's going to be 5/2, or 2 1/2 hours spent biking. We're going to write as 2.5 here and 1.5 here. Well, and again, remember we're trying to answer the two distances. That's what we're trying to find. And we've now found 2 times. So that's not going to give us our answer. What is going to give us our answer, though, is to find the distances. So 20 times 2.5 is 50, and 8 times 1.5 is 12. So our distances are 50 miles spent biking, and 12 miles spent running. And we can check our answer very quickly. In fact, we did when we came up with it. 2.5 plus 1.5 sure enough is 4. 20 times 2.5 is 50. 8 times 1.5 is 12. 50 plus 12 is 62. So step 6, or step 5 rather, our check, we just verified on the table that everything works out. And our answer for step 6 is to put this down for both of these. Now make sure that you're very, very, very careful on a multiple choice test. I'd be prone to have one of my answers be 50, one of them to be 12, and then I'm probably going to throw the 2.5 on there as a red herring answer because you found it, right? We found 2.5. That's what our variable came out to. But 2.5 isn't the answer to our question, so we can't select it.